Welcome everybody. My name is Andrew Vanage, and you're going to have the next 2 days or 2 afternoons with me to learn CBRS and private LTE. So thank you all, number one, for registering for my session. Hopefully you're on the cutting edge like we are at Celona with new technology, new wireless for enterprise applications, and it'll be very informative and a good time the next 2 days. So a couple of housekeeping items before we get started. There is a sign-in sheet circulating around. Make sure you check your name off of there so we know that you attended. Ozar will be happy to mail out the materials that we go over the next 2 days for you. So as you're going through this material, it can, it's new technology for a lot of people. First introduction to some of these concepts. So don't worry about taking too many notes. All the material you see up here will be available to you, and we'll send it out later tonight. So you'll have it as reference. Today, why are we here? CBRS is new spectrum that's been opened up, and it's a good opportunity to learn it because it's going to impact a lot of people in enterprise wireless. So today we want to go over some theory concepts to understand CBRS and LTE as a wireless protocol, since most of us might be familiar with Wi-Fi instead. Get practical to understand how to design and deploy for CBRS networks with LTE. And then tomorrow we're going to dive in and do some actual hands-on. You're going to get some experience. We've got a lot of iPhones that we've brought with us. You get some hands-on time with an actual device running on a private LTE network. And we'll go through some test scenarios so you can see how it works and kind of what some of the characteristics that you can expect out of it are. So today, expect mainly theory, and understanding the protocols and the spectrum aspects. Tomorrow we'll dive in more hands-on. Today we're going to cover both CBRS and LTE. From a housekeeping perspective, we'll probably take a break in the middle of the session somewhere as we break between those two topics, so you guys can go get coffee, get water, take a bathroom break, and then we'll come back and we'll dive into LTE. So hopefully you guys aren't too fried from other deep dive technical information that you've heard today, and you're relatively fresh to learn some new content, because there's going to be a lot of it coming at you. So the other thing that I wanted to mention is I want it to be very interactive today. So as we go through this content, please raise your hand if you have a question. I would be more than happy to attempt to answer your question. I am a Wi-Fi person by background in enterprise networking. I'm learning LTE just as you are. I just might be a little bit ahead of where you are potentially. So I may not have all of the answers to your question, especially if you have a very deep technical question, but I'll do my best. And some of the deep content or questions that we get, we'll be able to answer tomorrow when our CTO joins us, who has a long history and experience in the cellular industry. So happy to take any questions as we go. Just raise your hand again so I can repeat the question for the video crew at the back. We are recording this session, so it will be available publicly at some point. I don't know the specifics around that yet, but just so you're aware, it is being recorded. So the agenda, so I talked about this, whoops, too far. Come on, backwards. Backwards. Okay. Wow, it really went forward. So today we're going to do CBRS, planning a CBRS network, and LTE. Tomorrow I will actually dive a little bit into vendor content. I'm with Celona. We manufacture a private LTE solution for the CBRS spectrum today. We're going to go a little bit into our solution just so you understand how not only our solution operates, but also what some of the key characteristics are for cellular networks compared to mobile operator networks that you may be familiar with, because there are some differences in how they're architected and designed. And then we'll do the hands-on exercises. So, and then join us tomorrow night as well for the evening session. We're going to have a panel discussion with a few Wi-Fi experts and a few LTE experts from both sides to do a comparison of Wi-Fi and LTE from a technical and a use case and application perspective, so you can understand how the two technologies, what their strengths and weaknesses are, and how to position each one when you're looking at going into your customers' environments or in your own environment and looking at which technology makes the most sense for any given deployment scenario. We feel they're very complementary, and we'd like to have some time to discuss those comparison points. So let's dive right in. Let's get into CBRS, which stands for Citizens Broadband Radio Service. CBRS has been commercially available now since the end of January, and it is built off of LTE and upcoming 5G. So CBRS, when you think about it from a technology perspective, think of it like you think of spectrum bands for Wi-Fi. You have 2.4 gigahertz and 5 gigahertz for Wi-Fi. CBRS is really the spectrum band and the properties around that spectrum. It's not a protocol or a technology implementation per se itself. So on top of that spectrum, we either use LTE or upcoming here pretty soon in the next year or so, 5G. So just so you understand, there's a lot of confusion out there talking about CBRS networks, private LTE networks, just so you know the relationship there. CBRS is really like new freeway lanes. It's new spectrum that you have to increase your capacity in an enterprise environment, and it has a couple of key characteristics that you should be aware of. It has less interference because it's very lightly used today. The incumbents that we'll get into are very sporadic and very limited use throughout the continental US. The ecosystem has adopted LTE and 5G in the spectrum, so there's not really any Wi-Fi in the spectrum or other protocols operating. It's really all going to be LTE or 5G. And the FCC has set up coordinated use with what we call a lightly licensed model. That means it's shared spectrum, and there's a tiering structure to the sharing. So it's not completely unlicensed. You can't just go out and use it. You can't buy off-the-shelf components and just deploy one at home. So it's kind of a hybrid in between licensed spectrum, where mobile network operators pay a large amount of money for dedicated access to spectrum, and unlicensed, where anybody can kind of buy an off-the-shelf product and use it. So it's in between. You have to have an off-the-shelf, you have to buy a solution, but it also has to have not only FCC certification, but it also has to integrate in real time for operations with what we call a spectrum access system that we'll get into. And there's 150 megahertz available, and the channel sizes range from 10 megahertz, 20 megahertz, or 40 megahertz. Now, in cellular that we'll get into when we get into the LTE protocol specifically, we have a concept of component carriers, which is the size, the bandwidth coming out of any one radio or cell. And then we have carrier aggregation, which is kind of like wider channels in Wi-Fi, but it actually, in cellular, it aggregates multiple radios in a unit that overlap with the same sector. So in CBRS, we have, it's broken down into 10 megahertz channels as far as licensing goes. So there's going to be some priority access licensing as one of the tiers coming up, and that's going to be broken down into 10 megahertz channels. But the radios are capable of operating in 20 or 40 megahertz channels as well. And that's going to give us about 200 meg download and about 50 meg upload, best case. And the radio power levels range from 30 to 47 dBm, depending on indoor versus outdoor and some other characteristics. I don't know what's going on with this. Sorry. So timeline. This started back in 2010 when the NTIA put out a fast track report. They wanted to prep the market for introduction of new wireless technologies and to free up additional spectrum to meet the growing capacity demands that they were seeing in the market. And part of that, they wanted to open up 500 megahertz for new broadband initiatives. So this is where the seed of CBRS kind of came from, is identifying federal incumbent spectrum that could be refarmed or shared in order to provide more mobile broadband for consumer and private enterprises. In 2012, they built on top of that with the FCC put out a notice of proposed rulemaking on 3.5 gigahertz, which is the CBRS band, for small cells and spectrum sharing. 2014, they put out the rules from the FCC, and the WinnForum started work in 2015 on the Spectrum Sharing Committee and the CBRS standards development process for this specific spectrum band. So really, the seeds started to grow there with forming rules around the spectrum in 2014 and 2015. In 2016, the CBRS Alliance was formed, which is more like a business alliance to promote the use of CBRS as a technology, and their other charter is to adapt LTE for use in this band, mainly taking LTE as it is and adapting it where necessary to meet unique business requirements for enterprises deploying in this specific band. The initial standards were published in 2017, and then just a flurry of activity between 2018, 2019, and 2020. So 2018, we have this concept that the FCC adopted for initial commercial deployment, which is kind of testing the water of CBRS. They didn't want to just allow it to start working. This is a very unique shared tiered spectrum with a shared cloud database and the spectrum access system. They wanted to test it out first before we completely open it up for commercial deployment. So ICD, or initial commercial deployment, commenced late last year, September of 2019. And that really allowed people to start using the spectrum on a limited temporary authorization basis. So you could apply to the FCC for a temporary authorization to deploy a CBRS network in a given facility or location, register it. The FCC would either approve it or deny it based on the characteristics in that location and of the testing you needed to do. And they were going to learn through that process through here early 2020. And hopefully through that learning process, we would find that things worked as anticipated and things worked well with the spectrum access system to protect incumbent users. And they did find that, so here in early 2020, they actually opened it up for full commercial deployment. So CBRS as a spectrum band is fully authorized now as of late January of this year for deployments. The phase we're in right now then is that we've got infrastructure manufacturers going to the FCC to certify devices right now. There's a small subset certified. A lot of other manufacturers are going and certifying devices in progress right now. And we have the 5 spectrum access system database vendors that are fully approved as of the end of January. They've been approved by the FCC that they're handling the spectrum grant process to protect incumbent users. They're handling that sufficiently. So that's what full commercial deployment means, is we're ready to go live, go through the certification process, start deploying networks as long as you're certified and integrating with the SAS. So it's still a very, very new technology, even though the seed has been kicking around since 2010 or 2012 with the band. Really, we've only had live deployments since September of last year, and very, very, 3 weeks into full deployment type of mode. What organizations should you keep an eye on in CBRS? There's 2 primary organizations. The WinnForum. This is really a standards development organization, so think of it analogous to the IEEE for Wi-Fi. This is the group that defines the standards for the CBRS spectrum band. And then there's the CBRS Alliance, which is the business alliance to promote the technology as well as then to adapt LTE for use in the band. So CBRS Alliance is really more of a consortium of business-minded interests coming together, identifying business requirements, and adapting LTE where necessary with extensions in order to work in the 3.5, 5 to 3.7 gigahertz band. You have a question? So the question is there any interoperability testing? Yes, both on the WinnForum side, they have certification of devices that to conform to integrate with like SAS. There's various protocols actually that for the coordination of the spectrum that the WinnForum tests and certifies for. So there's like SAS to CBSD, and CBSD is essentially the AP component. There's SAS to SAS because all the various SAS vendors sync their databases on the back end. So there's a lot of protocols involved, and their certification takes that into account. On the CBRS Alliance side, they're also doing some certification, mainly for OnGo branded certification, and that's more for the LTE side, that things conform to the CBRS LTE kind of unique features. So here's some of those certifications that I was just mentioning. So WinnForum is, you're always one slide ahead of me, David. The SAS has a bunch of different standards that they cover. So SAS test specifications, CBSD test specifications, which is the AP side. The database, there's a PKI component for authentication, and there's various protocols for, again, the SAS to CBSD for spectrum grant and release. There's SAS to SAS protocols for the back-end database fidelity. And each one of those goes through a testing and certification process. The other one of note is that there's certifications for the ESC, which is the environmental sensing capability. This is how SaaSes kind of protect incumbent users. We'll get into a little bit detail of what an incumbent is and what they're doing in the spectrum. But the environmental sensing is in those areas where incumbents are operating, the SaaS is mandated to deploy sensors to detect for the presence of those incumbent users, and then dynamically switch users off of those frequencies as required in those very specific areas. Question? Can you define SaaS? Oh yeah, so SaaS is Spectrum Access System. So it's essentially, there's 5 vendors. It's Federated, Google, CommScope, Sony. Oh, and I always miss the 5th one. There's another one. Sorry if I forget which one it is. There's 5 vendors that have been approved by the FCC, and they maintain like this back-end database where every radio that operates in CBRS has to register with their system, inquire for what spectrum is available at a very specific location that device is going to be installed in, and then the SaaS will grant them access to a slice of spectrum. And so this is a dynamic process, and we'll get into a little bit about how that works as well. And the other thing I should mention is, as part of attending this course, you are all also going to be able to go through the last certification aspect down here, a certified professional installer. And these are training courses that the SaaS providers give to get certified to understand how the system works and to deploy particularly high power outdoor radios because you have to kind of certify that they meet and you're putting in valid data of the valid location, the valid power, antenna gain, azimuth that it's direction at, so they can tell the impact to the incumbents because they do some modeling on the back end as well. Question? Who are the typical incumbents in the spectrum? We're going to get to that. So hold off on that. The question was, who are the incumbents? We're going to get to that in just a little bit here. So from a certification standpoint, the SaaS vendors themselves have to be certified that their sensor capabilities can actually detect the incumbent signatures. So if you're in Wi-Fi and you're very familiar with radar detection with DFS, for instance, this is analogous to that, but it does not operate the same way. So rather than have every CBRS radio dynamically sensing itself for radar signatures, the SaaS is responsible for that on the back end. So they're deploying sensors out in those areas. You don't even have to worry about it. If the SaaS detects it, they will inform the radios that are impacted through the SaaS to CBSD protocol. So from that aspect, one of the things that I talk about is DFS has sometimes suffered in the past in Wi-Fi with false positives and false negatives and things like that. Much higher fidelity from a CBRS perspective because they're out there deploying specific sensing that meets the incumbents, and like the DoD is one of the main incumbents, their strict requirements for fidelity of detection of those signatures. So you don't have to worry about it based on manufacturer's implementation. So the SaaS vendors are going to be deploying? Yeah, so the question is, are the SaaS vendors deploying these ESC sensor networks? And the answer is yes. Nothing that any end user, partner, you don't have to worry about it. As long as you subscribe to a SaaS and your equipment checks in with them for the spectrum grant and licensing process, you're covered. FCC Regulations, just a link so you know where it's at. It's under Part 96. So if you look at the FCC Electronic Code of Federal Regulations, you look under Part 96, which is about CBRS. So if you go to ecfr.gov, look for Part 96, you can read. The FCC requirements are actually pretty thin. It leaves a lot up to implementation, which is where the WinnForum comes in and says, if I have to meet this FCC and DoD requirement, how do we actually go and implement that?